My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. I am Flash Isaac and you are welcome to 120 Days to Jamb Physics, episode number 60. We are done with reflection of light. Today we shall be introducing refraction of light. Waves have certain properties: reflection, refraction, polarization, and blah blah blah. Ladies and gentlemen, if we agree that reflection is the bouncing back of light when it encounters an obstacle or when there is a reflecting surface, what then is refraction? Let me begin this way. If I give you air, you can do like this in air. If I give you kerosene, you can put your hand inside, dip your hand inside kerosene and do like this. If I give you palm oil, you can dip your hand and do like this. If I give you engine oil, you can dip your hand and do like this. But you notice something. The resistance you get from flinging your hand in air is different from when your hand is inside kerosene, and it is different from when your hand is inside engine oil. Engine oil is thicker than the other substances mentioned. Engine oil is more compact than the other substances mentioned. That is the concept of density. How compact, how close, or how thick substances are. And mathematically, we'll say that density is mass per unit volume, mass over volume. So what is mass of that substance in every volume? If I give you this space, this volume, what is mass of that substance that can be in this volume? That is density. Now, what is refraction? Apart from reflection, light can refract. Refract means bending of light. Light can bend, can bypass as it moves from air to another density, or as it moves from a substance of one density to the other. This is what I'm trying to say. If this is air and bottom here you have, let's say, water or glass of water, so this is straight like this, a horizontal line. So if we draw something like this, this becomes the normal and this becomes the normal. Normal is an angle perpendicular to the surface that we are dealing with. This is the surface in question. So let's shine light this way, like this. If you shine light this way, we call this the incident ray. Correct? Correct. From our knowledge of the reflection of light, we know that the angle the incident ray makes with the normal is the angle of incidence. This is the incidence angle. Now, if we are dealing with a reflective surface, you know that this light, this incidence will bounce back to give us the reflected ray, and here will be angle of reflection. But refraction is not in that case. For refraction, it is not going to bounce back, but since it is coming here and it has encountered this boundary, which is water, it will change direction. So when you shine light from air to water, you will see there is a change in direction. It will bend. So that bending of light, as it passes through medium of different density, is called refraction. So here is the refracted ray. Just refracted ray. Incident ray. If it were reflection, it would be reflected ray. But for refraction, it is a refracted ray. Now, this is normal. This light is supposed to go straight like this, but it has now refracted. So here is the refracted angle or angle of refraction. So this is medium 1, which is air. This is medium 2, which is water. So that is the basic idea of refraction. Light bends as it passes through different density. You obviously see the bending. Apart from light, if you took a substance in water, then you view it through light, or you notice that the direction it has bent. These are normal day-to-day experiences. Just like we have the laws of reflection, we also have the law of refraction. And the first laws are a bit similar. The first law of refraction states that this incident ray, the refracted ray, and this normal, they all lie on the same plane, as you can see. The second law of refraction states that the ratio sin I over sin arrow is constant for a given pair of media. So if you are given like water to air to water, this to that, the ratio sin I over sin arrow is always constant for that given pair of medium. What is sin I? Sin I is the sine of incident angle. Sin arrow is the sine of angle of refraction. If here is 30 degrees and here is 25 degrees, this is the incident angle, this is the refracted angle or angle of refraction. Sin I over sin arrow will simply be sin 30 degrees over sin 25 degrees. So for a given pair of medium, so a particular type of medium, the ratio is constant. It does not really change. This bending of light by refraction makes it possible for us to have lenses, magnifying glasses, and prisms. By the way, this law sin I over sin arrow for refraction is what we refer to as Snell's law. Snell's law of refraction. Then once again, ladies and gentlemen, refraction can occur in plane surfaces or curved surfaces. For plane surfaces, we can see refraction in glasses, in water, and in air. Meanwhile, for curved surfaces, refraction occur in lenses. And we shall be looking at lenses in the future episodes in details. Ladies and gentlemen, it is time for certain formulas that you should need. For plane surfaces, these are formulas you will need to solve questions when it comes to refraction. These are formulas you need to handle certain questions. Refractive index. Refractive index is basically the ratio of sin I over sin arrow. Or refractive index is sine of the incident angle over sine of the refractive angle. And that is the Snell's law. Snell's law of refraction. That is the general formula. But there are cases or questions where you may have to bring out other formulas, or you may have to compare ratios to get what you are looking for. In that case, refractive index is sin I over sin arrow. It is the same thing as V1 over V2. Sin I is basically the incidence. If you are doing from air to water, air is your sin I is the incident, source of the incident, while the second medium is the source of the refraction. So for air to water, sin I is the angle of the air, arrow is for the water. Now, this is the same thing as V1 over V2. V1 is the velocity in air, velocity of light in air. V2 is the velocity of light in the medium, let's say water or air to glass. If you are dealing with a refractive index, know that for waves, V is equals F lambda. V is frequency times wavelength. So if refractive index is v1 over v2, which means it is the same thing as f lambda 1 over f lambda 2, frequency times wavelength of the first medium over frequency times wavelength of the second medium. But look at this for you, very important. Refraction occurs at constant frequency. So during refraction, frequency is constant. Frequency does not change. So as such, you can ignore the frequency here and say refractive index is the wavelength of the first medium, if we say air, over the wavelength of the second medium, if we say water. So the frequency does not change. So these are the top formulas for refractive index. Before we take a look at this question, look at something very important. Now we know that refraction is bending of light. It is bending of light. And this is the normal. Light can either bend this way or bend towards the other side. So on what ground does the bending occurs close to the normal, or on what point does it bend away from the normal? Look at this, very important. This is air and this is water. You know that water is thicker, is more compact, it is denser than air. So since the light is moving from less dense to a more denser medium, it will bend towards the normal. This is the normal. So it will, as it's coming like this, it will bend this way towards the normal. At that point, the angle of incidence is less than angle of refraction when it is moving from a lighter to a thicker medium. Now, if it is from a thicker medium to a lighter medium, the ray it will bend towards this side, making the angle of refraction bigger than the angle of incidence. So from less dense to dense, the bending is towards the normal. From dense to less dense, it bends away from the normal. And that is a past question as well. Now, light of velocity 3.0 times 10 raised to the power of 8 meters per second is incident on a material of refractive index. If velocity of light is reduced to 2.4 times 10 raised to the power of minus 8 meters per second in the material, what is refractive index, or what is N? That is refractive index. Ladies and gentlemen, I told you in physics, when you are given a question, look at the data. What are you given? What is it saying? And what is it not saying? One thing we are sure of is we are looking for refractive index. And we are being told that we have a light of velocity is incident on a material. So the light of velocity is 3.8 meters per second, and that is the velocity of light in air. So this medium basically tells us that this is air. So let's say velocity in air. How do I put it? Should I say VA? Okay. Or let me say V1. That is air. Is equals 3 times 10 raised to the power of 8 meters per second. Now, the velocity of light reduced when it encountered an obstacle, when it encountered a material. So they did not tell us that this material is water, is glass, or whatever, but we know that it has changed from air to another medium. So the velocity, let's call it V2, is now 2.4 times 10 raised to the power of minus 8. Is that what it is? Yes. So what is the question? Find the refractive index. The only things we are given here are velocities. We are not given any other stuff. And from here, I told you that refractive index is sin I over sin rho. It is V1 over V2, and it is lambda 1 over lambda 2. So we are given V1, that is the velocity of the incident, or the first medium, that is air. That is the first medium they mentioned. Now, the second material is V2. We are also given that velocity to be 2.4 times 10 raised to the power of minus 8. So food is ready. The refractive index will simply be V1 over V2. That's the formula we shall be using. V1 3.0 times 10 raised to the power of 8. V2 2.4 times 10 raised to the power of minus 8. So everything should give you 1.25, like I've marked here. So that is the answer. This is 8. So this is plus 8. This is 8. So that is the answer. Please pardon me. Okay. So the thing is for you to get what it's all about. So anything they give you, just solve and you'll be fine. But this is this, and that is that, and this is your answer. The speed of light in air is 3 times 10 raised to the power of 8 meters per second. Refractive index of light from air to water is 4/3. Find the speed of light in water. We are basically given the medium air to water, and we are seeing refractive index and we are seeing velocity. So which formula connects refractive index and velocity? It is simply from what we did earlier, that we said that refractive index is equals V1 over V2. Now in this case, the refractive index is from air to water. You can do like that, A to W or whatever you know. And V1 becomes VA, like A is air. Now V2 is VW, that is V water. But the good news for us here is that we have the refractive index. They said it is 4/3. So 4/3 is equals. Another good news is that we have the velocity of light in air, which is VA or V1, to be 3 times 10 raised to the power of 8. So we are looking for velocity of light in water. So if you are very good at mathematics, when you cross multiply, the velocity of air in water becomes 3 times 10 raised to the power of 8 times 3 all over 4. This becomes 9 times 10 to the power of 8 over 4. So when you solve this, you should get 2.25 times 10 to the power of 8 meters per second. That is the answer. As simple as ABC. We said that this is the incident ray and this is the refracted ray, right? And you know that this thing is supposed to continue like this, but it deviated from how it should be. It has now bent to form another angle here. So this angle from here to here is called the angle of deviation. It is how it has deviated from the incident. You are supposed to go like this. You've now moved this way, so you've deviated by this angle. That is simply the angle of deviation. And if it were like this, from here to like this, when you look at this, it is supposed to continue like this, but it has now deviated like this or refracted this way. So this angle here will be the angle of deviation. So mathematically, the angle of deviation in this case, D, is equals incident minus refracted angle. That is the angle of deviation. For this place, if this is 30 degrees and this is 25 degrees, the angle of deviation is 30 degrees minus 25 degrees. That is 5 degrees. So take note of deviation. And one more thing, I told you that these formulas will be made clear later. I did not emphasize much on the formulas earlier. Look at this formula, very, very important. It says the refractive index of glass is the same thing as refractive index of air to glass if you have two medium. Which means for air to water, if you are given the refractive index of water, that is the same thing as refractive index of air to water. Applying that to the question we have before us, which says a beam of light is incident from air to water at an angle 30 degrees. So the incident angle is equals 30 degrees. Find the angle of refraction. Angle of refraction. If the refractive index of water is 4/3. So since we are given the refractive index of the thicker medium, we can say that, okay, that refractive index of the thicker medium is the same thing as the refractive index of the lighter medium to the thicker medium. And this is the same thing as sine I over sine R, like you can see here. So refractive index of glass, if you are given, is the same thing as refractive index of air to glass, and it is sine I over sine R or V1 over VR. And the refractive index of water to glass is the same thing as velocity in water over velocity in glass, and it is the same thing as refractive index of glass over refractive index of water. So all these minor formulas, they are very important. Deviation is equals I minus R. And please make sure you get the Flashlearners Jamb app, because you see a lot of questions there to play with, a lot and a lot. So from here, food is ready. The refractive index of air to water or of water is 4/3, and the incident angle is 30 degrees. So sine of the incident angle is sine 30 degrees over sine of the refracted angle. Mathematically, this becomes sine r is equals 3/4 sine 30 degrees, and r becomes sine inverse of this. So r is equals sine inverse of 3/4 sine 30 degrees. So I am not imposing any particular way of solving to you. So solve the way you know how to solve best, and you arrive at your answer. A ray of light is incident on the surface of water at an angle of 30 degrees. Incident angle is equals 30 degrees. Calculate the deviation suffered by the ray in the water. Deviation equals question. The refractive index of water is equals 1.33. A ray of light is incident on the surface of water. That means light incident on the surface of water, it is definitely from air to water. If you are shine light like this inside water, it is going from air to water. Now we are given the refractive index of water. We are given the incident angle, that is I. The incident is from air. We are asked to look for the deviation. Now look at something interesting that you should know, which I also explained in the previous episode. We are given the refractive index of water, not of air. So what is now the general refractive index, or what is the refractive index of air to water? The refractive index of air to water is the same thing as the refractive index of water, which is the thicker medium. And this is the same thing as sine I over sine R, and the same thing as V1 over V2 is the same thing as lambda 1 over lambda 2, as I've already explained in these formulas. But we don't need all this right now. So from here, food is ready. The refractive index is 1.33, which equals sine 30 degrees over sine R. Sine R is equals sine 30 degrees over 1.33. So R is sine inverse of sine 30 degrees over 1.33. So this will give you 22.1 degrees. And the last question, the answer should also be around that 22 degrees. Yes, around 22 degrees, that should be the answer also. Now, 22.1 degrees. This is the refractive angle, or angle of refraction. 1 degrees. But we're asked to look for the deviation. I told you that this is deviation. If you subtract the incidence angle from the refracted angle, you are going to get deviation. From here, D is equals I minus R. So I is equals 30 degrees, R is 22.1 degrees. So that should give you your deviation. 30 minus 22, that is 8. 30 minus 22.1, that is 7.9. So that should be your angle of deviation. Ladies and gentlemen, I hope you found this interesting. Let me know how you feel, and please go and install the Flashlearners app by visiting flashlearners.com or the various stores, and go to physics and choose refraction. You see a lot of questions, and if you choose the study mode in the app, you see answers. So they are there to help you get exposure to a lot of questions. So this is the videos are to guide you, teach you what to do, the apps to solve more questions. And if you have any problem solving questions in the app, just screenshot and send to me on WhatsApp. See you in the next episode.